AP Cram, Calculus AB, Free Response, Exam Review. Question 62, Area of a Bounded Region, Integration. Okay, so let f of x equals 2x squared minus 6x plus 4, this curve right here, and g of x equals 4 times the cosine of 1/4 pi x, this curve right here. Let R be the region bounded by the graphs of f and g as shown in the figure. So the intersection of these two regions bound the area R, okay? Our task is to then find the area of R. So how would you go about doing this? I'll give you a moment to think. It's pretty straightforward. All right, so in order to find the area of R, we're obviously going to have to integrate. And for some people, that might not be so obvious, but just think about it. The area under the curve is always equivalent to the integral of a function. Therefore, in our case, the area of this bounded region is going to be equivalent to the area under the curve of this function, which is g of x, minus the area under the curve of this function, which is f of x. And subtracting f of x is important because then it leaves this area, the area of overlapping for g of x and f of x. And we also need to establish our bounds of integration. So they first are bounded on the left-hand side at 0, and then again at 2. So these are going to be our limits of integration. So the integral from 0 to 2 of g of x, okay, minus f of x dx, because we always have to have our dx. All right, so now what we have to do is actually plug in the functions. So it's going to be the integral from 0 to 2 of 4 the cosine of 1/4 pi x, okay, minus 2x squared minus 6x plus 4 dx. So what we're going to do is first factor out constants and integrate each sum term by term using the power rule over here for f of x and using u substitution over here. The only tricky part about this integration step is the u substitution. Okay, so basically we know that this is going to be u. We're going to let u equal pi over 4x. And if you didn't know, now you know that this is what you have to do. So you have to integrate the outer function, which is the cosine. And just in case you didn't know again, whenever you integrate cosine of something, you get the sine of that something, okay? So if u is pi over 4x, then our du is going to be pi over 4 dx, because we got rid of the, whenever you integrate with respect to, the variable x, and there's only an x, you get rid of the x. So our du dx, our derivative of u with respect to x, is just going to be pi over 4. But, so we have to kind of, let me show you what I'm talking about. Excuse me on the time lag, but our du dx is just going to equal pi over 4. because what we did essentially was differentiate with respect to x, and that gets rid of this x. Now when you rewrite this, we have like the 4, the integral, from 0 to 2. I'm not going to write that because my drawing tool is too slow. The cosine of u. But we also have dx, okay? No, actually du, where du is equivalent to pi over 4 dx. But we didn't start off with a pi over 4, so this is the tricky part. To offset this pi over 4 to get rid of it, we're just going to put a 4 over pi out here as a constant, and that takes care of that pi over 4, okay? So this is the tricky algebraic manipulation that most people might not be so familiar with, but that's that. So then we get 4 times our pi over 4 that we got from u substitution times the sine of the cosine, because, we're integrating the outer function of pi over 4x, and this was our u and u substitution, minus, okay, in this case, we let n equals 2 times x to the n plus 1, where our n was 2, so n plus 1 is going to be 3, divided by n plus 1, which is also 3, minus 3x squared, okay? And that comes from the fact that our n right here was 1. And so if we multiply by n plus 1, we're going to get 2. No, if we have to raise it to our n plus 1 and then divide by our n plus 1. So we get raised to the second power divided by 2, and that's why we have 3 here. And then here we have x to the 0. So then our n plus 1 is going to become 1, and then we have to also divide by n plus 1, which is 1, which we don't have to represent here, okay? So this whole entire spiel right here is our antiderivative, and we evaluate it from the upper limit to the lower limit. And when we do that, it simplifies to 16 over pi minus 16 over 3 minus 12 plus 8. So what you do is you plug in 2 wherever you see an x, and then you evaluate that expression, and then you subtract and you put 0 in wherever you see an x, and that's just going to all be zeros, so it cancels out for 0. So essentially we're just evaluating at 2, okay? And that further simplifies to 16 over pi minus 4 over 3. And this is our answer. Okay, so you can do the math here if you want to, but this is a fine way to express the area of the bounded region R. So it's 16 over pi, so